project, and let's get it rolling. Welcome, guys. I will hand you the baton. Is it Jan? You are muted, and so if you muted yourself, you will have to unmute yourself. Stephen, you look good. You're ready to go, and I can, as soon as I see Jan Michael unmute himself, or if one of my producers can try and unmute him. There we go. Folks, here we go. I'm going to let you guys take over. And I'm actually not going to join the auction. It's too crazy. I want to hear what you guys have to say.
Thanks, Ryan. Hi, my name is Stephen Marklevitz, and I'm here today to give you this presentation. Just let me flip over my screen so that everyone can see the presentation that we will be sharing with you today. There we go. Hopefully everyone can see that. So I think this is our return to the Muskie Odyssey. We were here in person a couple years ago with a booth demonstrating this work, but I'm excited to be here today to give you an update of what we've been doing in the last couple of years and where we are at with the project. So just to, hold on a minute here. So just to introduce ourselves, my name is Stephen Marklevitz. I'm a fisheries ecologist with the Ministry of Natural Resources and Forestry here in Ontario. And I'm joined here today by Jen Michael Hassenauer, who is my counterpart with the Michigan Department of Natural Resources. And we form two of the team that is implementing this project, with Jan being the ringleader of us all, trying to wrangle all of us into line when we're implementing this project. So I will be giving the presentation, and then Jan and I will be here to answer questions at the end. So here we go. So just as, if you've seen any of my work or any of these presentations in the past, some of this may be a repeat, and I apologize, but we'll go through it anyways. For us here in Ontario, the Lake St. Clair Muskie project really began because we knew surprisingly little about muskie, especially muskie in large open water lakes. And when I mean little about their movements. So some early research had demonstrated that they're capable of moving great distances away from spawning locations, upwards of 100 kilometers. I believe some of this work was with Steve Lepan out of the St. Lawrence, in the St. Lawrence area. And then through some work with some of my other counterparts, Runis and Chris Wilson, which I believe you've either heard from or will be hearing from, we know that they're likely returning to their spawning locations year after year, much like salmon might, but luckily for all of us that these don't die like a salmon would. But this really leaves a huge gap in their life history between those events, and that leads us to some assumptions. Some of the assumptions we've made or have been making is that these are simply sit and wait ambush predators that are likely not moving around a lot. They're lurking in weeds, potentially waiting for a forage fish to swim by, lunging out, eating it, and returning. But really not, they may be moving around a home range, but they're really not, we made assumptions that they're not moving around that much. As far as for this is an issue in Lake St. Clair, because we have a world-class, as I heard in the last section too, we do have a world-class muskie fishery here. Large catch rates, not unheard of for 4 to 6 within a very small fishing window. We've heard of upwards of a kilometer of fish caught, linear feet of fish caught in a single fishing day on the lake as well. So very high catch rates. With not knowing this information, what that means is that we really don't have the capacity to properly design assessment tools or programs so that we can really understand what's going on with the fish population. And that's really where this project is trying to fill in some of those gaps. So as this was alluded to already, This project is a partnership with some of our key U.S. partners. Jen Michael with the Michigan Department of Natural Resources. We also have partners with the Ohio Department of Natural Resources and the U.S. Geological Survey. So there's a lot of people involved here. And we could not have implemented this project to date without our valuable community partners, Muskie's Canada, in particular the Belle River Chapter as well. Muskie's Inc. in the U.S. and their Lake St. Clair chapter, and the Michigan Muskies Alliance. A lot of tongue twisters with Muskies and Michigan there. So each of these groups have helped promote the project. They've fundraised and helped donate equipment or purchased equipment directly and given it to us, and countless hours of volunteer time to help us catch the fish that we can then tag. So we're very, very grateful, and the project success and what you'll see in the rest of this presentation could not have been accomplished without these valuable partners. The project has three key objectives. The first is to look at stock structure and dispersal. So in particular, we have a pop-up fishery that occurs every now and then in West Basin of Lake Erie, and we really had no idea where these fish were coming from. So, that's one of the questions, and whether or not the Lake St. Clair fish may also move upwards into Lake Huron is another important fisheries management question. Habitat use. So on the Canadian side in particular, we were interested or are interested in understanding the use of the Thames River and whether or not we have a resident population that or a resident component of the population that sort of doesn't ever leave the river, or do we have a transient population or some combination of the two? And then also with that habitat use and movement, are they using the nearshore, offshore environments of the lake as well? And then finally, the third objective is the behavior and mortality. And these acoustic tagging, which we'll touch a bit more on in just a little bit, has proven to be really valuable in understanding our mortality from a year-to-year basis. So anyways, those are the three key objectives. I'm going to move on here and describe to you a little bit about what we do. So to tag these fish, we first have to catch them. And we've done this through either angling or electrofishing. So the angling is where the support from specifically the Belle River Chapter on my side of the lake has really valued the program. We've caught upwards of 20 fish in a day to tag. And so without that, we would not have been able to tag the numbers we have. Electrofishing we do as agencies a little bit more for some obvious reasons. Danger is one of them. Electricity and water don't always mix too well when you've got a lot of people participating in that activity. So once we get our hands on the fish, we tag them. So we're tagging them with a Vemco V16 acoustic tag. You can see a picture of this just down here on the corner of the screen here. Hopefully you can see my mouse. And then we also give them an external tag, which is the orange tag in that lower corner of the screen here as well. This way we can both visually identify them as well as that acoustic tag is out there pinging away and feeding data into the system. And then the worst part of the whole project, I'm sure Jan can contest to this, is the sitting and waiting for the data to return. So before we can, it takes about 2 years to get a full record of a fish on any given year. So for example, fish we tagged this year, we won't have a good understanding of what it did in 2021 until about 2023 once we get all the data back. This project is part of this larger GLADOS network. That GLADOS stands for the Great Lakes Acoustic Telemetry Observation System. This is this binational multi-agency and academic partner initiative. And it really allows us to leverage funding and support for individual projects to benefit every project within the system. So for instance, the Muskie project we're doing, the infrastructure we purchase also will feed into all of the other projects. So as I mentioned, the way the system works is that we implant those acoustic tags into the fish. Those acoustic tags transmit audible signals. Right now they're in the 69 hertz, so they're above what we can hear. So you can't really hear them if you pick up one of our fish. The hydrophone receivers that are deployed across the lake, they pick that signal up. So this is much like the hydrophones, if anyone had seen the movies on whales, listening to whale song. Very similar device to those. listening for those distinct pings that come out in a distinct pattern that then tells that receiver that individual passed it at a particular time. And all that data is captured within these receivers. And luckily for us, in Lake Erie and Lake St. Clair, we have the most extensive receiver array in the entire Great Lakes currently, which allows us to understand and investigate some of these fine-scale movement patterns. So being the most extensive array in the Great Lakes also likely means we have the most extensive acoustic array in the world at this point. It's a pretty fantastic system to be able to do this work in. So as far as progress on the project to date, and again, a lot of this has to do with thanks for the support from Muskies Inc. as well as Muskies Canada, and in particular the Belle River Chapter. We've been able to purchase and deploy 6 receivers into Lake St. Clair. We're currently maintaining on the Ontario side 5 of those. The one we kept losing, so we've abandoned that particular site so that we don't lose any more equipment. And then we also have 4 receivers that are going up the Thames River on the Canadian side. On the U.S. side, there's 6 receivers that go up along the coast, including into Anchor Bay. Really happy to report, thanks in large part to an initiative Jan facilitated this year. We've been successful at acquiring 30 additional receivers directly from the GLaDOS network to deploy in the upcoming year. So we'll be able to fill this grid pattern in fairly extensively in the very near future. Also in Ontario, we have a walleye tagging project that we've implemented on the Thames River, and we have 16 receivers that will be going into the Thames River right up to Fanshawe Dam. So the coverage in Lake St. Clair is about to get a lot more dense as we move forward, which is fantastic for our muskie project. As far as tagging fish, so the fish have been tagged in the Detroit River, Anchor Bay, Thames River, Belle River, as well as in Lake Erie. To date, we've tagged a total of 143 fish. We believe around 104 of those are definitely still alive and swimming around the system, with 14 with the detection histories that make them questionable whether or not they're still alive or not. So we're fingers crossed they are. So we have somewhere between 104 and 128 fish still around out in the system swimming around, which is really good. And then we're moving into our final year of tagging this year, so we should be able to add around 30 to 35 new individuals this fall. Fingers crossed on being able to get out there and do that field work. So that's all great. But that's probably not why anybody's here today. I'm pretty sure everyone would like to see what is going on with these individuals. So I'm going to just preface this a little bit here. I'm going to show a video. These will be fish moving away from their tagging locations. The tagging locations will be color coded according to these colors here. Don't get too excited. Not every dot is a unique individual. There's a bit of a delay on the dots so that we can see general movement patterns as well. So anyways, I will play this and I'll try to annotate it as we go along. But you'll start by seeing the Detroit River fish migrating away from that initial tagging event, and followed by the Thames River fish that just came on there. These would have been tagged in 2016. Your Belle River fish are about to pop up here. We started tagging those in 2017, and you'll see them swimming around the system there. The black dots across the system are the receivers and when they are deployed and when they've been retrieved. The green individuals there that just popped up were Anchor Bay as we move through 2019. Yeah, so what we can see here is a lot of movement, and I showed this to a colleague not too long ago, and they just wanted to they pointed out to me that the movement even in St. Clair is not trivial. Lake St. Clair is quite a large lake. The scale of this map does not do it much justice, so we have a lot of individuals moving around a lot. When we put all those dots on a map and then slow it down to look at how those fish moved, this would be the number of unique fish detected on a given receiver. What we notice is that we have a lot of fish that do move into the west basin of Lake Erie. they're not just simply using that nearshore environment. In fact, they're swimming across the open water of that West Basin. We have individuals that do move down the entire length of the lake or out past West Basin into the Central and East Basin. To date, those are comprised of 3 different individuals. We'll get back to those in just a minute. And then we have fairly limited movement up into Lake Huron. And in fact, to date, we've only had a detection of 1 individual. And that was actually just from our most recent data poll less than a month ago. So very, very limited movement up the St. Clair River into Lake Huron at all. Again, looking at the data, what have we seen in the trends? We've seen that most of our Canadian fish are spending most of their time in Canadian waters. You can see that here with the Belle River fish, and the Thames River fish spending most of their time in Ontario waters. We're also seeing that the Thames River fish are the least likely individuals to leave Lake St. Clair. You can see them here. So this is the Thames River fish. The green is Lake St. Clair. The black is Detroit River. The blue is Lake Erie. So again, most of those individuals do not leave Lake St. Clair, whereas we're seeing that even in our Belle River fish, some of those individuals moving down the Detroit River and into the West Basin of Lake Erie. And in fact, the fish that were tagged in the Detroit River are the most likely to be found in the West Basin at this point in time. So some pretty interesting movements and why even for example, the Anchor Bay fish are spending half their time in U.S. and Canadian waters. Well, the Canadian fish aren't is a pretty interesting question and definitely has some importance to how we manage and how we look at the fishery moving forward. So in our analysis, we have a new paper out. I'll make a pitch for that in the end of this presentation. But we looked at the average daily movement of these individuals just to give us a concept of how far these fish are moving. So on an average day over the entire season, these fish are moving around 881 meters. To put that into sort of a better context of things we might actually understand, that's about 10 football fields. So that's a lot of movement for these individuals that we thought hunkered down in the weeds and sat there and waited for prey to swim by. The range of those movements are anywhere from 4 to 14 football fields within a day. So, on average, they're moving 10, but that range is more or less for any individual on average around 4 to 14 in a day. The maximum we saw was around 30 football fields in a day, or around 2.8 kilometers. And the minimum of that was about 42 meters, or around half a football field. So that's sort of the range of the movement that we've seen so far. Probably not surprising to many people on this call. The fall is when we see the greatest amount of movement. The movement in the spring and the summer seem to be about even, with the least amount of movement being in the winter. The other important thing we're seeing here is we have a few fish that are really shaking up our understanding of these individuals. So while we may have been wrong on our concept of them being sit and wait ambush predators, I don't think anybody ever expected these fish to be as migratory as some of the ones we've seen. So I'm going to call these individuals our movers and our shakers. If you've seen a presentation before, you'll know about James Bond or heard the radio coverage, radio or TV coverage we've gotten for this. So James Bond was a male tagged by Jan off of Belle Isle in Michigan. He was a male, about 1 meter long, about 6 kilograms in weight, tagged in 2016. This will play a video here quickly of his movements. Just to take note, every time there's a red dot, that's an actual detection on a receiver. The blue dots are interpolated, so we're trying to fill in the gaps between the actual detections of those individuals. Each dot roughly is about 1 day, and there's a 10-day delay on those dots, just to put it all into perspective. So in the first summer, this individual swam the entire length of Lake Erie before returning to overwinter in the West Basin of Lake Erie. He returns each spring, more or less, to the Detroit River. In his second year, he spent in Lake St. Clair, again, before heading south and overwintering in the West Basin of Lake Erie. You'll see him move back up to Detroit here. And in this third summer, make that transit down the lake again to roughly outside of the Grand River, I believe it is. before he comes back again in the winter, overwintering in that southern part of the lake. Spent his third summer in the West Basin of Lake Erie. Actually, I believe it was his fourth summer, sorry. And then from the best we can tell, he seems to have spent some time potentially in Lake St. Clair in 2020. But we don't have a full detection history quite yet. So that's that 2-year delay that I mentioned earlier. So pretty much blowing our assumptions and some of our concepts of what muskie are capable of out of the water with this individual. But what's more exciting is he's not the only individual that we have in tag that has displayed this. We have another individual tagged off of Belle River. So this is a Canadian individual. Again, he's a male. Again, roughly around a meter long, 100 centimeters-ish. This individual did a slightly different migration route. He comes down the Detroit River, appears to swim by Point Pelee, likely along the Canadian shoreline, shows up off of Port Stanley, then swims across the widest part of the lake before we don't get any more detections of him somewhere off of the Sandusky Bay in Ohio. So last detections we have of him is 2018, and we're hoping that we'll be able to get a few more detections when all of the receivers are recovered, which we were where there were some hiccups last year with being various work conditions with COVID. But the other interesting thing to note, we do have a third individual that does do a migration, much more similar to the route that James Bond or Bond took for on this end. As far as what we've learned from the study to date is that these fish are not simply sit and wait ambush predators. They're moving around a lot. Sometimes this is over a defined distance. Sometimes this is over great distances and between water bodies. The movements appear to be seasonal, potentially like a bird, where they're showing up at roughly the same location year after year after year. A really good example of this is the fish that we've tagged in the Thames River in the fall. Those same individuals are coming back to that site every year, whereas the individuals we're tagging off Belle River, for instance, don't show that same return to the Thames River at that time. So it's not a whole muskie fishery showing up at the Thames River in the fall. It's a select group of individuals. And what we're also seeing is that the fish seem to be moving to and from Lake Erie, but that movement up into Lake Huron is relatively limited, which is pretty interesting given that the St. Clair River and the Detroit River are fairly similar as far as flow and temperature goes. So there should be nothing preventing those fish moving up the St. Clair River into Lake Huron. And it's a pretty interesting ecological question, and it also has some pretty big implications as far as how we manage and how we look at the management of this fish species into the future. Anyways, I told you I was going to make a plug. The great and a really exciting thing for us as a core research team is that we were able to put out the first peer-reviewed publication from this research, which has some of the results that were presented here today in it. If you're interested, I believe Journal of Great Lakes Research does have a period of time where there's free access. If not, get a hold of myself or Jen Michael and or some people at Muskies Canada also have a copy of this. So we will help facilitate what you might need from this publication. And anyways, at this time, I just thank you, and I thank you for all of the work and effort that everyone has done to facilitate this project, the fundraising, the volunteering, and everything Muskies Canada has done for us over the last 5 years as we implemented it. Thanks a lot. There it is.
Okay, Jan, your mic unfortunately is muted. So if you can unmute your mic, take it away.
Oh, no, I don't have a lot to add. Great job, Stephen. Thanks all you guys for your help and support. It's been wonderful. It's been really a great example of what can happen when we work together, scientists and anglers and different agencies. So I'm glad to answer any questions that any of you folks have for myself or for Stephen. But really nice job, Stephen. That was a good talk.
Well, it is, and unfortunately, there aren't a lot of questions because I think you've absolutely dumbfounded people with all of the science that you guys have been doing. But just off the top of my head, what's the future hold for the telemetry project, as well as any future species that you might be adding to a similar program?
I'll go first, Jan. So on the Canadian side, again, I alluded to that walleye study that we're starting. It was supposed to start like next week, but we've been pulled off that one for this year by the looks of it. So that one we do have in the works. That one's ongoing. We are currently also tagging Lake Whitefish in the West Basin of Lake Erie. We have a walleye project in the Grand River as well. So, and there's a burbot study coming on in the East Basin as well. So those are some of the other tagging projects go. We are also implementing a muskie spawning site survey. So this study will be using our electrofishing boat in the nearshore habitat along the southern shore of Lake St. Clair and into the Detroit River to try to identify those spawning locations. We're using some of the acoustic telemetry to help narrow that down a bit. But again, this is to try to help us identify locations that we can start to implement an assessment program in the future with. Along with that is a visual tagging study. So we're looking at mark recapture of those individuals. So if you guys catch a tagged individual, what's absolutely critical for us is that you get a hold of somebody, if it be Jan at the Department of Natural Resources in Michigan or somebody out of my shop, and report those, because that's how we are going to start estimating population size, and that's the data we need back. If there be the acoustic tag or the non-acoustic tag fish, absolutely critical that you report your tag fish. We're only doing it from an assessment standpoint. In fact, in a lot of cases, we don't even care where you caught it. We just care that it was caught. So I know some people have hesitated in the past in reporting, but that's what we're doing. Please report.
I was just going to ask, is there any other way an angler can help out or get involved with this science, with this program?
Yeah, so with that, you can always call into the Natural Resources hotline. That's sort of this most simplistic way of doing it. We're in development of a reporting web-based tool. It's not going to be ready in time for this year, but stay tuned. It's pretty exciting that you'd be able to just log onto the internet and report your tag, and then somebody will likely contact you at some point. Or you can give us a call at our office. Those phone numbers are available if needed.
Right on. The great question here from Rolf. Do muskies travel up the tributaries at any time? He lives near a source in the Belle River area, and he swears he sees big fish in the shallow water. Is there any truth to that?
So in the Thames, we have a receiver. We have a couple of receivers right near the mouth to look, because that's where a lot of the muskie fishery occurs. And then we have a few. We have one all the way up in Chatham, and then we have one sort of that splits the difference between the two. What we're seeing is they're not moving that far upstream there. The other tribs, I don't know what's going on in those particularly, but we are noticing that in the Thames that the ones at least we have tagged are not moving that far upstream, a kilometer or two at most. But they're not hitting Chatham.
Right on. This is actually a fantastic question. It was going to be one of my next ones, was the quality of habitat as well as water. How much have you seen any effects on water quality in terms of where muskie will migrate to or their condition visually?
I'll start. Jan, I don't know if you've got more on your side, but on our side, this is part of what we can't do right now. We have such a limited ability to do any assessment that being able to link trends we're seeing to anything from VHS to habitat quality to habitat quantity, we just simply don't have a good enough assessment tool. for these fish. They're very hard to assess. We've caught them in trap nets and other fishing gear in the past, but none of that gear is actually designed to capture them. So the catch rates are almost irrelevant from any type of assessment. We know when we have high catch rates, the population is likely high, but we have no good ability to do that. So it's at least on our side, that's a question that we can't answer now, but we're hoping to be able to answer in the future.
Did you want to add to that, John? Go ahead.
Yeah, there's some really exciting stuff that we can do with this telemetry data as it kind of piles up, and we have the opportunity to look at more of it. I'm thinking sort of in the sense of like, from a remote sensing point of view, if we can take satellite imagery of like the lake conditions, algal blooms happening in Lake Erie, even, water clarity type stuff, and kind of overlay that with where the fish are, we can probably do some correlative work there. It's something that's in the future that at least we've kind of had in the back of our minds, but haven't been able to apply the data yet. And part of it's just not having enough detections yet. And we're starting to get to that point now where some of these fish have been out there long enough. And as Stephen showed, are showing similar behaviors year after year. And you can kind of relate some of those things, but it's really big picture, water quality stuff rather than, actually being out there and having hands on the fish, kind of like Stephen mentioned. But certainly is an exciting possibility, and what this type of work is well suited for in the future.
Right on. Any concerns on Lake Erie when it comes to the perch population? Is it having an adverse effect to the muskie at all?
It's really hard to say. There's so little information on muskie and Lake Erie at least from my agency's point of view, that some of this telemetry work is some of the best info that we've gotten to date. So, I think it's really, really difficult to in any way tie those two together right now. I'll let Stephen wade into that one a little bit too, but
no, that was going to be pretty close to my answer. Yeah, we just don't have enough information. Likely not. The perch populations in Erie are it's Central Basin, and from our acoustic telemetry, it's Central Basin that we're having some trouble with, and from our telemetry work, most of them are sticking to the West Basin. So, but again, we just don't know enough at this point in time.
Right on. I've heard, obviously some warm water species, as we know, have turned over to goby as a part of their diet. Any truth to muskie also consuming goby?
You don't want us to do a diet study. That would require us killing these fish. So no, we haven't. We are not actively doing a diet study on muskie on our side of the border. Jen, have you guys done any diet work?
We did a little bit of diet work a few years back through lavage methods, meaning like stomach pumping rather than cutting them open, which is it can be a little bit more limited than the alternative, but it's generally viewed more favorably. And I don't recall gobies. I don't have the details of that work off the top of my head, but I don't recall. I mean, it was mostly what you'd expect, soft rayed fishes, suckers, minnows, that type of thing that were showing up in the diets. This was in Lake St. Clair. I think it was a U of M grad student that went out with, I think, a few different anglers to get our hands on some of these fish. So I mean, it was what you'd expect, and I don't recall gobies being a big part of that diet, and neither were some of the other fish species that people are worried about a lot, like yellow perch or walleye. I don't recall those being in any way a big part of that diet.
Now, with your telemetry program, obviously it would have been impacted by water levels. The fluctuation that we're seeing from year to year is incredible. Did any of that play into how your research, or at least some of the answers to your research, came to you?
Not really. So one of the things we've learned with the GLaDOS network is that you don't touch receivers once you've deployed them, i.e. you put them right back exactly where they were. So the higher water levels really did not change any of our grid, our receiver deployment locations. I spoke about that muskie survey that we were doing. So we did a preliminary year on that a couple years ago. And we did note that, there was the areas that we would have expected to find muskie may have shifted there. But again, we just know so little information about how this all relates. because we know so little about how they're moving. And this is part of what the value of this study is really unlocking some of that mystery around how they're moving. So in the future, we should maybe potentially be able to better identify what high water does for these fish. It may be beneficial. It may not be. So.
No, absolutely. And really the jury's out on that. Obviously low water levels in the Great Lakes isn't a great thing for anyone, including the fish. But the high water levels, we see it. The fluctuations they're just incredible. And what it's doing to these fish, I guess we'll never know. I'm going to bring in Ryan, and hopefully Ryan's with us. And
that is at a tremendous amount.
You're in, Ryan.
It looks like someone has added me into the Muskie's official. Guys, I'm leaving the auction stream, and I am going to the Muskie's Canada official stream. I will catch up with the auction later.
I just wanted to turn it over to you, Ryan. Yeah, I wanted to turn it over to you so you could thank our two illustrious guests here who gave us a wealth of knowledge when it came to the telemetry program that they've been involved with, and I'll let you take it from here.
All right, guys. Was I saying your name right? Is it Jan Michael?
Either or is fine.
Okay.
I usually just go by Jan, but I've been called a lot of things.
Well, I had a high school friend, and if someone called him Jan, they would only do it once. And so I'm very sensitive to making sure people's names are pronounced properly. I didn't get to hear a lot about this, but because I'm a member of Muskie's Canada, I have learned a lot about the telemetry, and I think it's super cool. They're going to use the work that you guys have done to expand and train other people on how to do this and help multiple species of fish, not just our beloved muskie. And so I think it's super great. I'm going to say farewell and thanks to you guys, and they can put me solo on the screen. And if you were watching perhaps from another channel, if you're not on Muskie's Canada official, you better get over here because you're about to get cut off. So we are now technically ahead of schedule.